Venus, a lost Eden and the search for life beyond Earth. Venus, our closest planetary neighbor, is a world of striking similarity and stark contrast to Earth. In size, it's nearly a twin, with a diameter just shy of Earth's, making it one of the most Earth-like planets in our solar system. Its mass is roughly 80% of Earth's, and its density suggests a composition of rock and iron not unlike our own. Beneath its surface, Venus likely harbors a partially liquid iron core, wrapped in a silicate mantle and capped with a crust that's thinner than Earth's, but still substantial. Yet, for all these similarities, Venus is a world transformed, a cautionary tale of what Earth might have been, or could yet become. What sets Venus apart is its rotation, a peculiar trait among the planets. While most worlds spin in the same direction as their orbit around the Sun, Venus turns the opposite way, a retrograde motion that puzzles scientists. Some theorize a colossal impact in its distant past flipped its spin, slowing it to a crawl. A single day on Venus, its sidereal rotation, lasts longer than its year, stretching out over 243 Earth days, the slowest spin of any planet. This sluggish pace, combined with its orbit, means a solar day on Venus, from sunrise to sunrise, is about 117 Earth days. This slow rotation robs Venus of a strong magnetic field, leaving it vulnerable to the harshness of space. The surface of Venus tells a story of relentless geological renewal. With fewer craters than expected, it appears young, perhaps 300 to 600 million years old, suggesting periodic global resurfacing events. Heat from its interior might trigger these cataclysms, repaving the planet in molten rock. Volcanoes dominate the landscape, numbering in the thousands, from small cones to sprawling giants over 150 miles wide. Venus boasts more volcanoes than any other planet, a testament to its fiery past. While we lack proof of current eruptions, hints of recent activity, perhaps within the last few million years, keep the question alive. Could Venus still be geologically active? Its atmosphere, however, is what truly defines Venus today. Thick, with carbon dioxide, over 96% of its composition, it traps heat in a runaway greenhouse effect, making Venus the hottest planet in our solar system, surpassing even Mercury. Surface temperatures hover around 470 degrees Celsius, hot enough to melt lead, with little variation from equator to pole. The pressure is crushing, 92 times that of Earth's at sea level, equivalent to the depths of an Earth ocean nearly a mile down. Yet, high above, some 30 miles up, conditions soften. Temperatures and pressures mimic Earth's surface, sparking dreams of floating habitats. Venus wasn't always this inferno. Billions of years ago, it might have been a very different place. Scientists speculate that Venus and Earth once shared a similar infancy. New land, nascent oceans, and atmospheres ripe for life. On Earth, life took root, but on Venus something went terribly wrong. Volcanoes, the same forces that nurture life here, may have doomed it there. Erupting vast quantities of carbon dioxide, they choked the atmosphere, driving temperatures skyward. Oceans, if they existed, boiled away, leaving no water to absorb the gas. No minerals cool enough to lock it into rock. Venus became a furnace, its potential for life seemingly extinguished. Yet the idea persists. Could Venus have supported life for billions of years before its fall? Its volcanic past offers clues. On Earth, volcanoes are dual-natured, destroyers and creators. They spew gases that shape climates and fuel ecosystems, from the hydrothermal vents of our oceans to the fertile slopes of Hawaii. Venus's shield volcanoes, vast and flat like those in Hawaii, hint at a similar role long ago. Lava plains cover much of its surface, scars of an ancient catastrophe that might once have been a cradle for life. If Venus ever hosted life, it was likely microbial, thriving in a wetter, cooler era before the planet turned hostile. This question echoes beyond Venus, across our solar system. Volcanoes, it turns out, are everywhere. And where there are volcanoes, there might be life. Take Io, Jupiter's fiery moon, a world alive with over 400 active volcanoes. Its eruptions, driven by Jupiter's gravitational pull, spew sulfur into space, painting Io in vivid reds and yellows. A lava world, too harsh for life as we know. Io teaches us that internal heat can power geology in unexpected ways. Then there's Europa, another of Jupiter's moons, cloaked in ice but hiding a vast ocean beneath. Tidal heating from Jupiter might fuel underwater volcanoes, mirroring Earth's deep-sea vents where life thrives in darkness. Could Europa harbor aquatic organisms, blind but sonar-guided, feeding on volcanic energy? Saturn's moons offer more intrigue. Enceladus, a tiny icy world, stunned scientists when the Cassini probe revealed plumes of water vapor and organic compounds jetting from its south pole. Fissures, stretched by Saturn's tides, hint at a subsurface ocean with conditions, liquid water, heat, and chemistry, ripe for life. Titan, Saturn's largest moon, takes it further. Larger than Mercury, it boasts a thick atmosphere rich in nitrogen and methane, with lakes of liquid methane. On its frozen surface, volcanoes here might erupt ammonia or water, sustaining a methane-based cycle. Could life exist here, breathing hydrogen, swimming in icy pools warmed by volcanic heat? It's alien, speculative, but not impossible. Closer to home, Mars beckons. 3 billion years ago, its volcanoes roared, building Olympus Mons, the solar system's largest peak. Towering over a landscape of ancient lava tubes, Mars once flowed with water, its crust now locked solid. Those tubes, formed by cooling lava, could one day shield human settlers from radiation, or perhaps already hide traces of past microbial life. Volcanoes on Mars, like those on Earth, might have seeded life in a wetter past, now lost to time. Our solar system is a tapestry of extremes woven by gravity, heat, and water. Jupiter, a gas giant 11 times Earth's diameter, spins in under 10 hours, its magnetic field a shield against the solar wind. Its great red spot, a storm centuries old, churns with ammonia and sulfur, a reminder of the chaos that shapes worlds. Saturn's rings, sculpted from shattered moons, glitter with ice, while its moons hint at hidden oceans. Beyond, the Sun itself, a yellow dwarf powering life, unleashes coronal mass ejections, magnetic storms that could cripple our technology, as one did in 1859. These forces, volcanic, gravitational, solar, drive creation and destruction alike. Water, too, is key. Earth's oceans, delivered by comets, made life possible, but Venus and Mars lost theirs. In the outer solar system, water abounds, locked in ice, flowing beneath surfaces, waiting to be explored. With billions of stars in our galaxy and trillions of planets beyond, the ingredients for life, water, energy, chemistry, are ubiquitous. The Drake equation suggests millions of intelligent civilizations could exist. Yet the Fermi paradox looms. Where are they? Do they self-destruct, hide, or simply ignore us? Venus stands as a mirror and a mystery. Once perhaps habitable, now a hellscape, it warns of fragility and fuels our curiosity. New missions, NASA's Veritas and Da Vinci Plus, Europe's Envision, aim to peel back its secrets, probing its geology and atmosphere for signs of a lost Eden. As we search, from Venus to the moons of Saturn, we chase a profound truth. Life may be rare, or it may be everywhere, waiting in the shadows of volcanic worlds. The universe, vast and strange, holds answers we're only beginning to seek. This script mirrors the original's focus on Venus's potential for life, its GU.